How do we solve this cubic equation? The trick here is that we are going to rewrite 14 x cubed plus s squared plus x is equal to 14 could be written as 2 plus 4 plus 8. This implies that s cubed plus s squared plus x is equal to 2 plus 4 could be written as 2 square plus 8 also could be written as 2 cube. Let's continue. S cube. Now let us move 2 cube to the left hand side. That will be minus 2 cube plus s square. Moving 2 square also to the left hand side, we have minus 2 square plus x. Moving 2 to the left hand side, we have minus 2 equal to 0. I can put these two guys in bracket. So I have s cube minus 2 cube plus s square minus 2 square also in brackets plus x minus 2 also in brackets, everything equal to 0. Recall that a cube minus b cube is equal to a minus b times a square plus ab plus b square. Take note of this identity. This implies that applying this identity to this guy, we simply have x minus 2 times s square plus 2x plus 4 plus s square minus 2 square is the difference of 2 square, and we can rewrite it as x minus 2 times x plus 2 plus x minus 2 equal to 0. You will notice that x minus 2 is common throughout. We can pull it out. So that will be x minus 2 into all of this, s square plus 2s plus 4 plus this guy, x plus 2 plus this becomes 1 equal to 0. X minus 2. Now let us drop this square bracket. So we have s square plus 2x plus 4 plus x plus 2 plus 1 equal to 0. X minus 2 into, we can add the common terms. So that will be s square plus 2x plus x, that is 3x, plus 4 plus 2, 6, plus 1, that is 7, equal to 0. This implies that x minus 2 is equal to 0, or s square plus 3x plus 7 is equal to 0. From this line, it is obvious x is equal to 2. This is the first solution. Now, let us solve this quadratic equation. We can solve it using completing the square method. So by completing the square method, by completing the square, the first thing we are going to do is to transfer this constant to the right hand side. So that gives s square plus 3x equal to minus 7. The second step is that we are going to add half of the coefficient of x and at the same time square it to both sides. The coefficient of x here is 3. So half of it will be 3 over 2 and square it. So we square it. Add 3 over 2 all square to both sides. S square plus 3x plus 3 over 2 all squared equal to minus 7 plus 3 over 2 all squared. Let's proceed further. This whole left hand side, we can rewrite it as x plus 3 over 2 all squared. That is, if you expand this carefully, you will have all of this left hand side back equal to minus 7 plus 3 over 2 all squared. x plus 3 over 2 all squared equal to minus 7 plus 3 square, that is 9, divided by 2 square, that is 4. X plus 3 over 2 all squared is equal to, what is the LCM here? The LCM here is 4. 4 divided by 1, that is 4. 4 times minus 7, minus 28, plus 4 divided by 4, that is 1. 1 times 9, we have 9. X plus 3 over 2 all squared is equal to minus 28 plus 9, that is minus 19, divided by 4. Now, let us take the square root of both sides. Doing that, we have x plus 3 over 2 equal to plus or minus square root of minus 19 divided by 4. X plus 3 over 2 equal to, I can rewrite this guy as plus or minus square root of minus 19 divided by square root of 4. So we have plus or minus square root of minus 19 divided by, what is square root of 4? That is simply 2. X plus 3 over 2 is equal to plus or minus. Also, I can rewrite square root of minus 19 as square root of negative 1 times square root of 19. But we know that square root of negative 1 is I from the complex number. So we have I times square root of 19. That means in place of this guy, we write what? We write I times square root of 19. I times square root of 19 divided by 2. This implies that x equal to minus 3 divided by 2 plus or minus I times square root of 19 divided by 2. This is another set of solution which is complex.